We are starting on page 33 today. We're going to talk about something called inverse functions. So the idea of an inverse function is that I'm going to take my domain and my range and switch them. So we're going to take essentially our x and y values and switch which one is the domain and which one is the range. So if I have a function that's f of a equals b, its inverse function would have the a and b swapped. So if g is the inverse, then that means that I have g of b equals a. So this means whatever sort of x values I have for my first function f that give me some y values for f, does the opposite with my inverse function. So this would be the x values, the domain for g, and these would be the range, the y values for g. Okay, so our input and output is switched for inverse functions. Okay, this down here again would be our inverse function. So we're going to take a look at some different options for what it means to be an inverse function, some different representations and kind of what that means for an inverse function. If we start with a relation map, okay, example A here, this would be our original function. Here's our domain, here's our range, and we can see everything in our domain is mapped to something in our range. For the inverse, I am switching the domain and the range. So this will be my domain, 2.25, 6.75, and 10. And then this is my range. So 2, 6, 10, 12. And then I map from here to here. So we've got in our original mapping, these directional arrows that say 2 goes to 10, 6 goes to 2.25. In my inverse function, I'm going to reverse these arrows. So 2.25 goes to 6, 6.75 goes to 10 and 12, and 10 goes to 2. That's my inverse relationship. Now notice I said relationship. This would actually not be a function because 6.75, our one input, has two different outputs, but that's okay. We're just looking at a mapping here to kind of get the idea of what an inverse relationship is. And then we'll talk about the functions a little bit later. Here for part B, I've got a graph. If I wanted to, I could pick out the input and output values, the points from this graph, and that's actually where I'm going to start. So we've got the point -2, 5. We've got the point -1, 0, 0, -3, 1, -4, 2, -3, 3, 0, and 4, 5, right down at the very bottom of our page there. So this is our original function. For our inverse function, we're going to switch the x and y's. So I'm going to list all the y stuff in the x column, 5, 0, -3, -4, -3, 0, 5. And then all the corresponding x values are going to go in my y column over here. So instead of the point -2, 5, I would have the point 5, -2, and 0, -1, and -3, 0, and -4, 1, -3, 2, 0, 3, and 5, 4. So these are the points on my inverse function graph, my inverse graph, I should say. So I'm going to go ahead and plot these. I've got the point 5, -2. I've got the point 0, -1, be right here. -3, 0. 0, -1 would be down here, sorry. -3, 0, right there. -4, 1, -4, 1. -3, 2, 1, 2. 0, 3, 1, 2, 3. And 5, 4, 1, 2, 3, 4. Okay. So this, also not a function, we failed the vertical line test here, but this would be my inverse relationship here. Okay, so inverse functions. We're switching the input and output, we're switching the x and y, we're switching the domain and range, however you want to think of it. We're switching these values. So let's take a look at some more examples on page 34. I'm going to turn the page here. Okay. When we actually get into function land, not just relations, but things that are actually functions, my function, f of x, whatever it happens to be, has an inverse that is also a function. If it has an inverse that is also a function, we can represent it with this notation. So this little sort of -1 exponent here is referring to the inverse of f of x. So this would be read as f inverse of x. So we've got a linear function here to start with. This is our original, our f of x function, and it's graphed here for me. So my y-intercept at -2, my slope up 2 over 3. So that's my graph I've got here. We're going to use this graph to answer some questions. So I want to know what's f inverse of 2 and f inverse of -4. So f inverse means I'm looking at having swapped the x and y. So for the original function, I know that my y value is 2. Remember, x and y are swapped. So when my y value is 2, what's x? Well, that would be 1, 2, right here. 1, 2, 3, 4, 5, 6. That would be 6. So with my inverse function, in my inverse function, remember the x and y values would be swapped. So f inverse of 2 would be 6. And the same is true here. If I look at the original function, because that's what I have graphed here, I don't have the inverse graph. If I look at the original function, I know that its y value would be -4. So when my y value is -4, that would be right here. That's 1, 2, 3, -3 on the x. Oops, -3. So for my inverse function, remember we swapped these. So f of -4 would equal -3. Part B, determine the y-intercept of the inverse function. So the y-intercept happens when x equals 0. So we're looking for that for the inverse function. Now remember, for our original function, okay, that means that we would be looking at when is the y equal to 0. Okay, so I would be looking for the x-intercept. Okay, the y-intercept of my inverse function comes from the x-intercept of my original function. So my x-intercept for my original function would be 3. That means that my y-intercept, I know this is confusing going back and forth, but my y-intercept for my new function would be 3. Okay. Here I have the point 3, 0. That's my x-intercept. So on my inverse function, when I swap their places, that gives me the y-intercept, 0, 3. Now let's go ahead and graph our inverse function. On the same set of axes, let's draw the graph for our inverse function. So what I'm going to do is list off the points from my original and swap them. For me, that's the easiest way to get that inverse graph. This is f of x, this is f inverse. So I'm going to pull the points from my original and then swap them for my inverse function. So this is the point 1, 2, 3, 4, 5, 6, -6, comma 1, 2, 3, 4, 5, 6. When I swap it, I still have -6, comma -6. Now for this guy here, 1, 2, 3, -3, comma 1, 2, 3, 4, -4. When I swap it, -4, -3 for my inverse. Here I've got the point 0, comma -2. So I would have -2, comma 0 on my inverse. This is the point 3, comma 0. So that would be the point 0, comma 3 on my inverse. And then finally, this would be the point 6, comma 2 on my original. So I'd have the point 2, comma 6 on my inverse. And let's go ahead and plot those. So -6, -6, that point's actually on both the original function and the inverse. And then 1, 2, 3, 4, 1, 2, 3. And then -2, comma 0. And then 0, comma 1, 2, 3. And then 2, comma 6. Here's the graph of my inverse function. Okay. Now, from the graph of our inverse function, we could write an equation for our inverse function. We know the y-intercept, we can find the slope of this line, but it would be nice if we didn't have to always graph that inverse function to be able to find an equation for it. So the next thing that we're going to look at is how to actually write an inverse function. So to write an inverse function, we have two steps. The first, switch x and y in your original function. So where you see an x, replace it with y. Where you see a y, replace it with x. Okay? And then step two, get y by itself, solve for y. Whatever that means for your particular function, solve for y. So let's take a look at example 3 here. We've got y equals 2x plus 1. So step 1, switch x and y. So this would be x equals 2y plus 1. Now I want you to notice this was a direct swap. I had 2x before, now I've got 2y. It's just swap x for y. Anything else that's going on in the function stays exactly as it is. I just pluck out the x and put in a y. Now I want to get y by itself. So for this little linear function, that means start by moving the 1 to the other side. I get x minus 1 equals 2y. And now I've got to divide both sides by 2 to get y by itself. So I get x minus 1 over 2 equals y. Or if I wanted, I could write this as 1/2 x minus 1/2 equals y. That would be my inverse function. I switched x and y, and then I got y by itself. Okay, so here's my inverse function. Either of these is fine. A little or in there. For b, same idea. This time I've got function notation here instead of a y. Remember, this still, for our purposes, means y. So this would be x equals y cubed. Again, I'm just swapping x and y. Nothing else changes. And now I want to get y by itself. Now, since I've got y cubed, I've got an exponent here, a power here. In order to get rid of that power, I've got to use a root. So since I want to get rid of a cube, I'm going to use a cube root. Or you could use a 1/3 exponent like we did in our radicals unit. That would be fine. But we get the cube root of x equals y. Okay, just one step there to get y by itself. We could also write this as the cube root of x equals g inverse of x. Either of these would be fine. Either of those is our inverse function. And then finally for c, same idea. Again, remember this means y. So when I switch x and y, I get x equals y squared plus 5. I'm going to start by moving the 5 to the other side. So I get x minus 5 equals y squared. And then to get rid of the square, I'll take a square root. And I get the square root of x minus 5 equals y. Or if I want to put it back in that function notation, I would have the square root of x minus 5 equals f inverse of x. If you put it back in that function notation, don't forget your inverse. Okay, so to find the inverse function, we're going to swap x and y and then get y by itself. We have one more problem we're going to take a look at for today, and that's interpreting. When we've got a context to our problem, what does that inverse mean? So for example 4, it says the number of people in thousands in a city is given by this function, p of t equals 20 plus 0.04t, where t is the number of years since 1970. In the context of the problem, explain what p of 25 and p inverse of 25 means. So for our original function, we're taking this time measured in years since 1970, and that's giving us the number of people in the city. So we have population as a function of time. So that's our original function. For our inverse now, we're swapping the domain and range. So for our inverse function, we're going to use time to give us population. Okay, so population is a function of time in our inverse. So population is a function of time, and then time is a function of population. Okay, I swapped that. Now let's talk about what this actually means when we put some numbers to it. So in the context of the problem, explain what p of 25 means. So in my original, that 25 would represent a time. So p of 25 means 25 years after 1970, that's when we're counting from, the population would be something. We could plug in 25 here and find that out, but we're just interpreting what this P of 25 means. Now for P inverse of 25, this time the 25 is not time, it's population. So P inverse of 25 means 25, and this is in thousands, 1,000 people live in the city some number of years after 1970. So P of 25 would give us the population of our city 25 years after 1970. P inverse of 25 would give us how long it would take, how many years after 1970, for our population to reach 25,000 people. Now, let's go ahead for part B and find P inverse of 25. So there are a couple ways that we could approach this, but I'm going to start with our original function. Since that's what we've got here, I'm going to start with our original function. So P of something equals 25. If I can find that something, that will tell me what P inverse of 25 is equal to. So I could plug that in for my Y value and find the X. So I would move the 20 over, I would get 5 equals 0.4 T. Divide both sides by 0.4, and I would get T equals 12.5. So since P of 12.5 equals 25, that means P inverse of 25 would equal 12.5. Okay. Now, the other way I could have approached this is to find my inverse function. So switch X and Y. And then get X by, or get Y by itself. So this would be X minus 20 equals 0.4 Y. Divide both sides by 0.4. Remember, it's the whole side. And that would give me my P inverse function, or of T. I guess I should switch this back to a T. Now I could plug 25 into here. If I plug 25 in for T, right, T inverse of 25, I would have 5 divided by 0.4, which is exactly what we did over here, and I would still get 12.5. So two ways I could approach that. Okay. Either way, what this tells me is that my population will be 25,000, 12.5 years after 1970, so about halfway through 1982. Okay, so that's inverse functions. We're swapping the domain and range. We're switching X and Y, which means if I've got a problem with the context, those sort of labels switch with me too.